In the summer of 2025, I decided it was finally time to turn the old basement into a proper man cave. And of course, it would make a great YouTube project. So subscribe and follow my work as I transform a 40-year-old unfinished basement into the home of my dreams with only 10,000 US dollars. Every woman I know said it's a terrible idea to park my car in the living room, but every man I know said it's a brilliant idea. One thing is important, there has to be enough space for a pool table. Everything else doesn't matter. This finger snapping transition video still doesn't work, but these do. As you saw, this is the first episode of the series. I really hope this kind of content works, because editing and narrating these videos is way more painful than the actual renovation. In this episode, you will see the installation of the doors and windows, the removal of the old electrical system, and the installation of the new one. I started the new electrical network by cutting the walls for the conduits and carving out space for the junction and mounting boxes. This is probably the hardest and dirtiest part of the entire project. I want everything to be hidden inside the walls. Even though surface-mounted installations would have been much more practical, I thought, if I'm already investing time, energy, and money into this renovation, then I shouldn't use external boxes, fixtures, and cable channels. At times like this, I really envy the advantages of American paper houses when it comes to electrical work. The old system stayed in place for the lighting until I finished the wall cutting. No matter how much I drew, planned, and tried to do the math, I couldn't power the whole lower level from one distribution cabinet. So I built the system from two cabinets, one with 12 modules and another with 24 modules. These cabinets will supply all the high consumption devices in the house: the two air conditioners, the upstairs kitchen, the downstairs kitchen, the electric vehicle charger, the oven and cooktop with a 3-phase connection, the water heater, the pool system, and other small things. The hardest part is that the concrete floor is fixed, so I can't run the conduits under the floor like in a new build. Everything had to be arranged on the walls. Unfortunately, this also meant I had to cut into the ceiling. The slab is solid poured concrete, and I really didn't want to grind into it, but I had no other choice. The 16mm conduits for the lighting were easy to cut into the plaster. The real problem was the two 3-phase circuits that also had to run across the ceiling. One for the electric vehicle charger and one for the upstairs kitchen's 3-phase supply. If you've never pulled wires through corrugated conduit, let me tell you, it's disgusting work, especially when you use solid copper wires. And since I didn't dare to cut the concrete slab any deeper, I simply couldn't pull 5 2.5 square millimeter wires into a 20mm conduit. Some wire pulls took me days before I finally succeeded. And since I didn't dare to cut the concrete slab any deeper, I simply couldn't pull 5 2.5 square millimeter wires into a 20mm conduit. Some wire pulls took me days before I finally succeeded. The spider webs also got pretty dirty. In the meantime, I also had a main water supply pipe failure, so I brought the water in through a new 25mm polyethylene pipe. I couldn't move this old boiler out because it weighs 270 kilograms. Maybe I'll connect it for heating during the winter so I don't freeze while renovating. Until then, At least it will still have some use. I also started dismantling the garage electronics. I built this about 3 years ago. It is driven by a refrigerator compressor and pneumatic cylinders. In the video, you can see me struggling because I forgot to disconnect more than one wire while removing it. It will get a complete rewiring because it will no longer operate from a central 24 volt power supply and control signal. It will also get some safety features like a locking cylinder and overpressure protection. I'm also going to build a wooden enclosure for it because like this, it would look really ugly in the living room. My old distribution board was a very ugly steel cabinet that was decommissioned from a hospital about 30 years ago. This cabinet housed the garage door control, electronics, the electric gate controller, all major consumers in the house, and even the workshop. I only made this setup temporarily around the year 2020, thinking that one day everything would be done properly. Well, it took 5 years to finally remove this temporary solution, but the moment has finally come. The cables hanging on the wall, quickly zip tied together, will also be removed. As an electrical technician, this sloppy workmanship had been hurting my eyes for a long time, especially knowing that I was the one who did it. And I hate sloppy work more than anything. By the way, the old electrical system that was originally built into the walls was made from large cross-section copper ground cables. Some of them are still in such good condition that I will reuse them in the basement and in the outbuilding. For example, I installed the old distribution board in the workshop. It is perfect there. It doesn't matter that it's ugly, at least it's easy to work on if I want to expand it. And finally, I've reached the point where all buildings have properly and safely installed electrical systems instead of patched together improvised solutions. At this concrete beam, I thought a lot about whether to drill through it or route around it. In the end, I decided that drilling through it would cause less structural weakening than carving around it. It wasn't easy to make the two holes in it. Thanks to the magic of video editing, it looks like a fast process here, but in reality, I was drilling for about 1.5 hours. This wall is underground on the outside. Since rainwater from the roof was not properly drained for 40 years, all the rainwater flowed here. Because this room also had no doors or windows for 40 years, the moisture in the wall froze and the plaster fell off. In the year 2024, I fixed the roof drainage and the wall started to dry out. When I installed the drainage system, I couldn't measure the moisture content of the wall because the meter maxed out. Today I can measure it and the moisture level is continuously decreasing. By May, it was already below 3%. So this year, I felt that the time had finally come to replaster it. For this, I removed the loose and weakened layers that came off easily. In the next video, I plan to apply the new plaster. It won't be an easy job. I've never done anything like this before. Timore. As I mentioned earlier, the garage electronics and pneumatic control system were completely rewired. I originally planned to finish the entire electrical installation in 2 weeks, which meant the garage door wouldn't work for 2 weeks. That way, the poor Skoda wouldn't have to spend too much time standing in the sun and rain. But reality had other plans. The poor car ended up standing in the yard for more than 2 months because I couldn't park it in the garage. In the end, however, the new electronics work perfectly and the enclosure is also finished. I built it from 19mm MDF boards. We have also reached the point of replacing the doors and windows. For 40 years, these wooden junk panels were here. They kept everything outside, except the cats and the cold. Replacing the doors and windows made a huge difference to both the exterior of the house and the interior comfort. Right now, while I'm editing this video, it is 14 degrees Celsius downstairs, while outside it is 8 degrees Celsius. With just one bucket of firewood, it gets up to 20 degrees Celsius downstairs. The door is 120 by 200 centimeters and the window is 100 by 100 centimeters. Both are double glazed plastic units. I chose white plastic doors and windows from the DM brand with double glazing. They are not the best on the market, but with a low budget, good value for money comes first. And in that regard, they are excellent. Luckily, the openings were more or less standard size, so I didn't have to grind or cut anything. That would have caused serious problems because the openings are cast in concrete around steel I-beam frames. All doors and windows were fixed using frame mounting screws and expanding foam. I also thought a lot about the video length. There was a lot of raw material and I recorded every small detail. I couldn't decide whether it should be long and slow or fast-paced. I watched a lot of successful videos on YouTube and most of them were in the slower category. So I leave you with a 1-hour video of my work. I guess nobody will watch it all. Since my previous video plans didn't work and didn't bring enough views or revenue, I had to move toward longer, slower content in hopes of higher RPM and a smaller but enthusiastic audience. My most popular video is also 1 hour long and has 3.4 million views, so maybe this is the right direction. I calculated that if 300,000 people watch this video, which is very realistic, half of the revenue could go into building my bathroom. The next video series and YouTube project will involve either building a masonry heater or a bathroom. I still need to plan this, and the decision also depends on how successful the video is. If you want to support my work, I launched the channel membership function, and you can also support me on Patreon or with a super thanks in the comments. Every form of support is a huge help and good feedback if you like my work. Since I decided I would no longer work 3 shifts for Eastern European wages, I quit my job in 2024. The balance of work, personal life, and mental peace doesn't work in Eastern Europe, so I decided to become a YouTuber. My goal is to earn 500 to 800 US dollar net per month from YouTube. The hardest part of my videos is narration. I struggled narrating with my own voice, but I realized that reading an English text is even more painful than building my basement. I didn't want to spend days reading 30 minutes of text aloud. My English speaking skills are not good, and I chose a faster video creation process. I felt I had to learn English, but now I feel it is almost impossible. I understand everything I read and hear, but I cannot speak it. And here, at the Broken Broom, I'd like to take the opportunity to say, if you like my work and would like to support my YouTube journey and the completion of my basement project, consider becoming a channel member. While I was cleaning, even a little bee moved into one of the holes. And then I'm wondering why I can't pull the corrugated conduit through. And here comes another unpleasant part, plastering. I fixed the mounting boxes and junction boxes into the car wet wall using a mixture of plaster and sand. Working with plaster is not easy because it sets very fast and you have to hurry. But when you hurry, you can't work precisely. Done on ceilings, plastering is one of the most disgusting jobs. The corrugated conduit doesn't stay in place, so it has to be nailed at first, which is difficult in a concrete slab and doesn't even hold very well. Most of the time, the broken plaster just falls straight into my eyes. Because I couldn't cut the ceiling deeper than about 25 millimeters, I had serious problems with circuits that contained many wires. On paper, 5 2.5 square millimeter wires should fit into a 20 millimeter conduit. In reality, they don't. The best thing I could do was to pull the wires for the two three-phase circuits into the conduit first, the ones running across the ceiling. One circuit goes to the upstairs kitchen and the other goes to the future electric vehicle charger. If 10 million people watch this video series, I'll buy a Tesla, since the wiring for the electric vehicle charger is already done. If 20 million people watch it, I'll buy a Mustang, and if 30 million people watch it, I'll keep my 20-year-old Skoda. Installing the distribution boxes was not easy either. This recessed in-wall solution looks much nicer than surface-mounted installation, but it also means a lot more work. I'm glad I chose the recessed version in the end and wasn't lazy. This means we are now past the hardest parts of the electrical work, installing the conduits and mounting components inside the walls. From here on comes the good part of the job, building the network itself, pulling the wires, installing the outlets and switches, and wiring the distribution boxes. I used 1 square millimeter wire for the lighting circuits and 2.5 square millimeter wire for the sockets and other devices. My main supply is 3 by 16 amperes. Originally, I wanted to build the main supply cables between the two distribution boards and the electric meter using 6 square millimeter wire, but that didn't work out. I'll talk about that later. Pulling the wires was probably the part where having one extra person would have helped the most. I ran into many obstacles during the wire pulling. Thanks to the magic of editing, it looked simple here, but it wasn't. There are many corners, many bends, and the wires are stiff. Not a good combination. The main supply wire I originally wanted was 6 square millimeter. I wanted to pull it into a 32 millimeter conduit, and that's exactly why I installed such a thick conduit in advance. So everything would fit comfortably. Well, that didn't happen. After a total of 2 days of suffering and trying, I gave up on the idea that I would ever be able to pull 5-6 square millimeter wires into a 32 millimeter conduit. So I spent more than $150 on wire that I couldn't even use. Pulling wires is much easier when one person pulls from one side while the other feeds and pushes from the other side. And of course, when you use cable lubricant. But nothing helped here, even though 5 by 6 square millimeter wires should fit into a 32 millimeter conduit. I wasted 2 full days and $150 from the budget. Sometimes I could cry when things don't work out. At this rate, I might not even stay within budget because of things like this. But I saved the easy part for last. The single phase, 3-core circuits and the lighting. Those went very smoothly. I like to get the painful parts done at the beginning. That's the best strategy. The outlets and light switches are only installed temporarily for now, before wall repairs and painting. I can already feel that the surfaces won't stay clean by the end of the work process. I also installed the outdoor switches. And outdoors as well, before wall repairs, I temporarily solved the lighting by wiring simple bulb holders. At last, my favorite part could begin. Building the distribution cabinets. I actually made these two cabinets during 2 sleepless nights, working in the middle of the night from about midnight to 4 in the morning for both of them. When creating the distribution boards, I first separated the protective earth wires, which are green and yellow in my country, from the neutral wires, which are blue. These go to separate bus bars at the bottom of the cabinet. I tried to keep everything neat and orderly, using zip ties to guide the wires like in a military formation, which is much harder than it looks. I divided the network into 3 residual current devices. In this small distribution cabinet, there is one 3-phase live protection relay and 8 circuits. From here, the current 2 air conditioners, a future air conditioner, the garage electronics, the pool system electronics, the living room lighting, and some sockets are powered. Everything runs from by13 miniature circuit breakers, except for the lighting, which is on B6. Thanks to the magic of editing and speed, this small distribution board seems simple, but it actually took about 3 hours of work. Next came the main distribution board. This one is split between 2 3-phase live protection relays with 3 3-phase circuits and 7 single-phase circuits. From this board, power goes to the upstairs kitchen, the basement kitchen, the basement bathroom, the basement mechanical room, the water heater, the kitchen and car area lighting networks, and finally the electric vehicle charger. I'm preparing for the day when I make it big on YouTube and can buy a Tesla for myself. A key difference with this board is that because of the 2 live protection relays, we also need 2 separate neutral wires. Building this main distribution board took about 4 hours. Here too, everything runs from B13 miniature circuit breakers except the 3-phase circuits, which run from 3 by C13, and the lighting, which is on B6. I couldn't believe it when it was done. Finally, I had heating, hot water, my kitchen worked again, and I could park the car in the garage instead of my poor Skoda standing in the yard, which is already half rusted. I no longer had to power half the house or light the workspace with a 100-year-old mercury lamp and battery-powered lamps. Living without these things for 2 months wasn't easy. I couldn't even make a cup of coffee. Another important step in preparing for winter was closing the cat portal. There is an old style underground window called an English shaft, which used to be popular for lighting basements. My friend János called it the cat hole because neighborhood cats used it to get in, but translated literally, that sounds ridiculous, so I call it the cat portal. I permanently removed the possibility for cats to sneak into my basement. Looking back, it had a very positive effect on the climate of the room. Before walling up, I also prepared a 110 mm PVC pipe outlet here, which will eventually carry the bathroom fan. My well and the main water supply also come in here. By the way, a video about the automation of my well and the water purification system will be coming soon. Subscribe so you don't miss it. When I built my garage door, I tried to pay attention to thermal insulation and air tightness. I think that even factory garage doors are not perfectly sealed or heat-proof, so I did what I could to improve it. When the garage door is closed, there is about a half-centimeter gap between the concrete and the T-profile. I saw a great solution on YouTube Shorts to seal such gaps. It is a rubber strip, specifically designed for sealing garage doors, which you can order from AliExpress. I am going to install this strip. I sealed the gaps between the wall and the L profile with expanding foam. I spread the foam well onto the sandwich panel as I worked. This greatly improved the air tightness. First, I tried placing the strip in position without glue to make it fit optimally. After opening it again, the tape was in the best possible position, which I just had to mark. For the glue, I used a 2-year expired adhesive, which surprisingly came out of the tube very slowly and set extremely slowly. But in the end, it worked, and it was free, so I made a good deal with it. Unfortunately, the concrete was uneven, so the rubber strip does not make a perfect seal. At the inner edge, you can still see under it, but it is 100 times better than before. I could have used more glue, but I won't take it apart again. Some small imperfections are fine. So this is where I am now. The basement is now prepared, so I can continue working, even in the winter cold, and hopefully finish my dream man cave by spring. Since it is much harder to work, while also filming and editing videos, and writing narration, I hope my video finds an audience and becomes successful. You can help by liking, commenting, or sharing. If you want to support my work even more, you can use the Super Thanks button in the comments, Patreon, or channel membership. So far, I have one supporter on Patreon, Devin Chase, who has been supporting me for a year. Huge thanks to him. Now a question for my most dedicated viewers. I have been following Justus Reed for a long time. He bought a $5,000 house and renovated it, achieving huge success on social media. I admire this success and want to try something similar. And as if it were a sign, I had the opportunity to buy this property for 4,500 US dollars. Even by Hungarian standards, that is cheap. About 4 to 5 months average salary in my country. Immediately, I thought this could be a YouTube project. The house is about 500 meters from me, on top of a hill, with a stunning view. I estimate that with another 6,000 US dollars, I could bring it to perfect condition. I would also install an off-grid water and electricity system. So, for about 10,000 US dollars, I would have an excellent YouTube project that could even pay for itself. I want to ask you, are you interested in this kind of content, or am I just seeing more potential than exists? Do you think I should go for it? My creative side really wants another long-term project where I can express my urge to create. Right now, even renovating my own house is moving slowly. Honestly, I estimate about 40% chance of success for the YouTube project. But that 40% could multiply the return on my invested work. In the worst case, like I said in the pool video, the YouTube video at least pays for itself. But now, in the worst case, I would get a small house on a hill with a beautiful view.